Then, I mean, man, thank you so much for making it, and super sorry that is, kind of late to you. Um, so yeah, I mean, it's super cool to have you here. Like, you are my new favorite LinkedIn creator. I just love all your posts. Like, no BS and straight to the juicy part. Yeah. So I don't know how you want to do it. We were thinking about, like, I was seeing that you were reading some paper about, fine tuning transformers, etc., LoRa's adapters, like two LoRa's, etc. And I was kind of wondering, if you would like to just show us a little bit of that stuff. Maybe we can have a discussion around it, because I like to me that's one of the most interesting things in the last year, right? Like, how to train this big stuff in a good way, and yeah, in a fast and cheap way. Yeah, please go ahead, do whatever you want. The stage is yours. Yeah, it's it's recorded, so now I am recording the Discord windows. Everything, man, everything. And I double check it before join Discord, because this time, I had two, I had two brain child working at the same time, and not only one. Hey, Mr. Robot. So yeah, feel free to share it. I don't know if, I mean, I don't think I need to give you any permissions, right? Yeah, I mean, yeah, but I also have Ubuntu, man, and to me it's better. But the Discord application on my Ubuntu just make all my system kind of lag, so I need to use Discord on the browser on Ubuntu for some reason that I don't know. Yeah, I guess that if you're able to share it, I guess it makes more sense, because then we can just follow from your mouse, etc. Uh, so maybe, so let's just see if you're able to do it in a little bit. Otherwise, we can just, yeah. No worries, no worries. I love your username. Ah. Nice. No, no, no. I think we are free from Italy. At least that I'm aware. Mr. Robot, I have no idea about your whereabouts. He can be everywhere. And Florian, I think that you are from Albania. And Jesus with sunglasses, which I think is the first time that we actually speak. And I noticed you on the Discord, because, like, The username was kind of funny. I don't know if you're also from Italy. Turkey, nice, nice. And Hamed Yassin, I don't know about your whereabouts as well, but nice. So we almost cover all the continents now. We just need somebody in the United States, right? Are you in the States, Mr. Robot? Yeah, but I think you got my prompt wrong. So I was wondering, where are you, like physically, now? I'm sorry, where? Is that in the right? So for you is late as well, right, Mr. Robert? Yeah. So like every time we have you here, and like it's like 11 p.m. for us, it's like 3 a.m. for you. Right. Man, you're a machine. Yeah. Yeah, but like also my father, which is now is like 63, it's a night person. So like he wake up at 10, 11, and he work till like 3, 4 a.m. It is, I mean, I don't know why. It's just, I don't know. Yeah, I just think that he prefers to work in the night because, I mean, at least when I was still living with my parents, so like he didn't have, the kids and the wife around. I guess. I don't know. I don't know. So, are you able to share the screen? Let's do this. I wait. Yeah, here we go. Here we go. I can hear him. It's a robot. Okay. So I kind of I have a question, man. I I have a question. So you know, by looking at people talking about it, like in LinkedIn, it seems like LoRa and adapters are two different approaches, right? So I don't know. Like, for what I very quickly understood, adapters is something that you place at the beginning, right? And you somehow adapt, you know, your new tokens to somehow be translated in the in your tokens that you had before. So I don't know if maybe, yeah, I don't know, maybe I'm just confused about that. And the advantage there is that the advantage uh, is that with adapter you basically you inject something that get fused on what on the pre-trained weights, but with LoRa, you know, you can just, you know, train them, and then you can just, you know, put in whatever you want, right? And you can put like more than one at the same time. Okay. Yeah, I use them a lot with stable diffusion, and Emanuele and I, we play a lot with a lot of LoRa's for not very Christian things, if I I can say that. And it was pretty neat because basically you can take like three or four of them, and you know, I don't know internally if they just get some or there is some waiting between them, but basically then, you know, you can have like a LoRa for good hands, a LoRa for certain type of, I don't know, hairstyles, etc., and you can just, yeah, you can plug and play them. And the cool thing there is that they are so lightweight, like they were like 5 megabytes, so it was so straightforward to, yeah, it was so cool. Yeah, 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 yeah. Yeah, and there is a lot of weird stuff on that website, man. And I was, yeah, and I was kind of wondering how the matrices, or like how the layers inside LoRa get initialized. Like, yeah. No worries. In the meantime, I maybe I want to ask a follow up. So, uh, so the input and the outputs from the LoRa. Uh, so where is the plus actually happening in the layer? So I was kind of wondering that, because like by looking at that picture, that's very general. Like to me, it looks like we have a classic transformer layer, and the input, it gets fed to the transformer layer and also to the LoRa, and then we do the summation at the end. But I think that you were talking about doing that to the attention matrix, right? So I was kind of wondering if maybe you can explain that a little bit, in detail to us, like where is actually the no, like which is the input and where do we do the summation. Yeah. So it's like one LoRa weight per like one for the key, one for the queries, and one for the values, or the same LoRa weights for all the three matrices at the same time. And I was also kind of wondering, like, so the input is just the input to the transformer layer, I guess. That's interesting because if you keep the keys the same, right? So if you don't change the keys, it means that you are still able to look at the previous information, without any change on them. So it kind of makes sense. Kind of makes sense. Um, I don't know if that makes sense to you. No, yeah, because I think that they say that they try to basically do the LoRa first on queries and keys, and then only on queries and values. And I guess it makes sense that queries and values works better, because it means that you have no, wait, but you don't do the summation before the attention. You do that after the attention. But if you no, wait, I'm kind of lost here. So I'm computing my LoRa, so one for the queries and one for the values, right? Then I'm just doing the normal attention with my queries, keys, and values. But where do I do the addition? Because I can do the addition, the plus there, because I can do the addition of the LoRa's for the queries to the queries before computing the attention, or I can, yeah, I kind of confused there. Like to me, still not clear. Like, where do I use them? Like, where do I do the addition? I don't know if for somebody else it's clear, but for me it's not. Yeah, like if we draw, right, like if we do a drawing on, like, the the original query schemes and values, and the queries and values, you know, created with the LoRa's. Like, where do I do the plus? So like, do I do, so I have my queries, right? I am computing my queries LoRa metrics, and then I do the plus, and then I compute the attention with the new query metrics and the old keys metrics, and then, you know, I basically do the same thing with the values as well. So I take the original ones, I compute the LoRa values, and then I do the plus there. Is that, I don't know if that's the correct approach? I mean, it would make sense. Yeah, maybe we can do a quick scan of the paper, like from top to bottom, and try to look at your notes as well. Like, I think it must be down there, because that's, I guess it's something original. Okay, so that's the method. So let's see. Okay, so no addition, inference, latency. Okay, and then we have our weight matrix that is equal to the original one plus b and a. Okay, I mean, that is like, that is what you were saying. Yeah, but then I guess it needs to specify something specific about the attention formula, right? Maybe down. Yeah, applying LoRa to transformers. So let's see. Okay, here say that we can apply LoRa to any subset of weight matrices. Of course, in transformer architecture there are 4 weights matrices in self-attention. So queries, keys, values, and I guess that's, what's the W0? Is that the MLP thing? No, what's W0? It's the projector. No. Like, what's W0 in the self-attention module? There just should be 3 matrices in the self-attention module. What is W0, guys? What's the third one? Is that C? No, wait, is that 0 or C? I'm sorry? Yeah, it's... Oh, yeah, of course. Yeah, of course, yeah. You're right, yeah. And then we say we treat, let's say, as a single matrix of dimension the model times the model. Okay. Only adapting the attention weights. Okay. So then, okay. So I think you do the LoRa things, you know, before you do the computation, like the attention computation, because then like it makes sense, because like you can do after you have done the... Yeah, but if you do it after that it means that the change to the matrices will be applied on the next iteration, right? Wait, let me bring up Paint Online. and let me try to draw something so we can use it as a way to understand if we all are on the same page, because I'm a little bit confused. I don't know if I am the only one. So let me also share my application. Okay, so this is a beautiful website. It's Paint Online. So yeah, okay, so I have my my queries. Can you see it right? Can I make this bigger though? Oh yeah, I don't know. Queries, keys, right? You know, we have the softmax, blah blah, and values, right? So then we say that our, so we would like to do q, I'm gonna say q LoRA, okay, is our q, and q, k, and v are frozen, and this is basically this BA that we're just gonna say this is BA for q, right? And then we do the same thing for the values, right? Same thing, so we have the original one, and then we do the B and A that we compute for values. Now my question is that we don't do this anymore, but we instead do Q, L, the original key, right? The softmax, blah blah blah. So this is the attention matrix, and then we do VL, right? So we take the original ones, we do the LoRa thing, and then we actually compute the output using the updated ones, right? Is that correct? It looks correct, right? Because this is still original, so it means that I compare my new self with the old information basically, and then I weight the new LoRa values with this with this P. I guess, right? I don't know. I'm looking for validation here. Oh yeah, but to me it's just a matter, you know. I'm going to do the update, you know, with the old frozen thing, and then compute the new values in this way, right? Or I'm gonna do something else, because to my very poor understanding, this is what makes the most sense. I mean, this is the only thing that I can think of. I cannot think on another way of doing that. But just because maybe I'm missing some knowledge here, so yeah. But let's have a look. Do you want to show it again? Maybe there is a more specific. Stop streaming. Maybe there's a specific, yeah. Because LoRa is it's very important thing, in my opinion. They're not really saying that in detail, right? Yeah. And I do believe that they only do this for a subset of layers, right? They don't do that for all the layers. Okay. Okay, interesting. I was kind of wondering if do they have how to say empirical study of like so what will happen if I just do LoRa's in some layers and not in others, or Yeah, but that kind of makes sense because if you do for the attention part, I mean, it will basically condition all the other stuff, right? Because then it will get injected by in the MLP. So I guess, and probably it's cheaper also, right? It should be cheaper than doing that on the MLP, I guess. I'm not sure about that. Oh well. Yeah, yeah, probably. I think you're right. Do we want to have a look at the code, and maybe we are able to find that specific part if the code is not um, too PhD like. Sorry for the PhDs in the. It makes sense. It makes sense. And yeah, maybe before we look at the code, I remember that I read something about that compared to just fine tuning, right? Like the old ways, doing LoRA basically mitigate the catastrophic forgetting of the model. And I was kind of wondering, like, what is your reasoning behind that, and why this is actually true? Because I guess it is true, right? But I was kind of wondering if maybe also here in the paper they kind of explain that in a more scientific way, because to me it makes sense, because you're not changing, the original way, you're adding more information, so you can change the previous one basically. But I was kind of wondering if they also have a more let's say scientific reasoning behind that. Yeah, because you basically have a copy of the matrices. Basically, you have the same size. Yeah. Um, Okay, so you are saying that it's better to use LoRa also compared to just fine tuning, just the last layer, right? So that's yeah. So basically, if you're not using LoRa to fine tuning, basically you're just stupid, right? Because it's straight, like it's a no brainer at this point. Yeah, alpaca. Yeah. Yeah, yeah. But it works for VITs as well. So this is also a powerful thing for computer vision as well. If you have a vision transformer, you can just use LoRa as well. And there is the library from Hacking Face. They also have an example using VITs, which is kind of crazy because these things that are using transformers in language, they're not really used in computer vision yet for some reason that I don't quite get it. Um, I mean, maybe it's because like you just have, so you're basically try to guide a lot of weight towards what you want. So probably it's much harder to optimize. Probably it's easier to just use the knowledge that you already have and just train a small part that will guide that knowledge, I guess. But it's not so convincing. It's kind of not straightforward. Uh, but yeah, yeah. Sorry. To optimize, right? Yeah, I think that's true. And another thing that people are not saying about this method, and this is why I. Yeah, yeah, and also there is a practicality. There is a very important practicality. I think there are three key points here. So first of all, is if I want to share my Finetune model with you, I don't need to send you like 7 GB of weight. I just need to send you 5 MB of that LoRa, and you can just yeah. And then second thing that we were talking about, that I can send you 3-4 LoRa's, right? And you can just include all of them, and you will have like new semantics or new styles or new things in your model if we're talking about stable diffusion. And another thing that is very important, I guess, in production environments, it's so much cheaper, to just have, I guess, a Docker image with the original weights, and then you download the LoRa's on the fly because they're just 5 MB, right? And it's cheap to inject them in the model. So this is really, really so beautiful, because not only makes fine tuning faster, yeah, yeah. Yeah, but control net is a different thing. So control net is basically, yeah, 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 cool. So do we want to have a peek inside the source code and see if we can find the actually place in which they do the LoRa thing inside the network? Yeah, but I mean, you want to do the summation to 00 before you compute with the x. But that, wait, but the formula there is not saying what I just said, because you're not doing the summation before computing the x. They are doing the summation after you compute the x with the original matrix, so the W0, and the LoRa matrix, so B and A. So I think that we have to have a look at inside the code. I mean, it's different if I do. No, yeah. No. I mean, this is. I'm sorry. So this is consistent. Yeah. Yeah. So let's have a look at the source code here, guys. So what do you think? What do you think? It it depends on the quality of the source code, right? So that's out of my hands. But we can just have a quick peek, and if we don't understand it fast enough, we switch to talk about something else. I can stream if you want. Microsoft LoRa. So let me Yeah, one sec, because first of all I need to create a new window capture on OBS and select that one, and then I need to transform to fit the screen. And okay, so, and then let me share it my screen. Okay, can you see it? Okay, so let's see if they have an example here, maybe can help us understanding. Okay, so here they are saying import LoRa libas LoRa, LoRa.linear. Okay, so maybe we can have a look at LoRa.linear to start. I guess it's here. Yeah. So let's see where it is linear. Okay, LoRa implementation of a dense layer. So it's using the method from LoRa layer. LoRa layer. It's just initializing. Okay, so software engineering talk. This is a bad pattern to do. So when you want it to inherit to multiple classes, like in this case, you shouldn't have two classes doing the init at the same time, because basically you have two classes that are possibly change the same state. So just, you know, and then I will switch off the software engineering critiques. So yeah, I guess the LoRa layers initialize something. It's getting this merge weight that is just a boolean. We initialize LoRa alpha and some dropout, and yeah, something we don't really care too much, just initializing a couple of variables. And then okay, here it's our A and our B. We have the rank, the in features, the out features, and the rank. I would expect them to be reversed, to be honest, like in features and R and out feature. Or maybe they transpose something. And then we have, I'm sorry. Yeah, because I would expect this to be in the. I mean, if I do A times B, I will get an R by R, right? But I guess yeah, but the first one in the LoRa paper, it's A, right? Right? It's B. Okay, well, and then it's perfect. So let's see the train. Okay, we are at this T transpose dot W. Oh yeah, so this is the transpose. This is our nn.linear.train. Yeah, but so why are they doing this? Because this is never stored anywhere. So why they are calling the dot train on the nn.linear, which is not even instantiated. nn.linear. Wait, are they? Wait. I'm very confused now. Why are they doing this? And why are they also doing this? Because this is not instantiated. They're passing self inside it. Ooh. Okay. So okay. So this is some hacky way. So since this is a linear layer, right? I can basically call the static method of the torch linear layer and say, hey, reset the parameters for myself, and here basically, you know, set the train mode to myself that way. Okay, so if train is true, right, I guess if the rank is greater than 0, sorry, so the mode is plus or minus apparently. Yeah, and this is basically yeah, so this is the thing for the formula. And then I guess we are interested in the forward, so we get our tensor here, right? and we do linear, and then we pass our weights. Okay. Okay, so it means that we first do the plus, and then we compute the thing with the x, right? Oh yeah, they're doing the plus again. Wait, this is not making any fucking sense, right? So why, when I call dot train, I will put my LoRa weight inside it, right? And then when I do the so here I'm changing my own weights, right? And when I do the forward, I basically using the x, my own weights change because we change in there, and then we do the you know, the LoRa stuff. Any idea? And not self dot merge. Okay, so this is important. So then I guess like here, if we call this we merge. Yeah. So okay, so if we merge the weights, no, so if this is true and this is true, make sure that the weights are not merged. So we remove our previous weight, so we remove our information, and if you want to merge, we merge it. Okay, it makes sense, but I mean, this is what we care, because here we are doing the LoRa computation. So like, I mean, this is kind of straightforward now. It's a little bit confusing in the code, but this is exactly so what we were seeing in the formula. So now I'm gonna look for the attention. I don't know what it is. This is from LoRa, we don't care. But where is attention? Merge. You're right. So let's yeah, but then how do I use it with oh boy. Well, yeah, exactly, but I would like to see in the code in which I actually do the thing for the attention. So so I kind of wondering, like, it should be here, right? It's if we're doing stuff for attention, it should be okay. So this is just a transformer library. So then I guess somewhere here they have something to add LoRa's. Somewhere here I see integration.py, which is not, this is, so all this thing is from transformers, so we don't have to look at that. But somewhere they have to have oh, this is, I mean, they need to have some code to do the LoRa things on a transformer, right? But where it is? LG source. Nice catch. I'm just gonna look for LoRa. Okay, here we go. So let me put it in the chat, the permalink, so we have it there. Okay, so here we are saying we are doing this merge linear, I mean, I think that we can understand what it is about, so we're just merging the matrices. Yeah, so queries, keys and values, I guess. Okay, then we have the C attention, that we can have a look of where it is actually used. That is here. Merge weights false by default because I don't think you want to merge at the beginning. Because like so merge weights means merge the weights at the beginning. To my understanding, or to my very weak understanding of the previous code, like you don't want to merge them immediately, but I think that we need to have a look at this inside. But here self dot attention is just, yeah, you get the attention. No, sorry, you get the attention. No, layer pass, no, you compute the attention here. So what you get from these bad boys, yeah, you get the free matrices back, in which, you know, we have done the plus LoRA stuff, right? And then we compute the attention. Yes, so we do the plus LoRA before computing the attention, actually. And if we go inside this bad boy again and we look at this guy, so let's go back on LoRA. Layers, blah blah blah, merge layers. Let's see. What's the catch here? We have in features, out features. We have enable LoRA, and then we create one big matrix, right? So this is the thing that you were saying, right? And if we look at the forward, it's very confusing, all this thing that they did. But yeah, I guess you just create one big matrix based on the number of enable LoRa's, right? Because here I can see a sum of enable LoRa's, so it means that if I have true, false, true, it's gonna be true, right? Because it's gonna be 1 0 1, so it's gonna be true. And then basically here I have basically double the rank, so like two matrices. I don't know, I'm the only one who is a little bit confused. I'm sorry. Yeah, but I think here, you know, in the attention code that we just looked here, we had true, false, and true, right? Because we don't want to run the LoRa. No, we don't want to change the keys with the LoRa weights. And here I can see that the new weights, in our case, with queries equal true and values equal true, are gonna be this is gonna be true, right? So my only confusion is that why this is not multiplied by the same amount. Because we're gonna use this. Right. 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 It makes sense. It makes sense. Yes. So we need to have a con 1D. Why do we need to have a con 1D now? Interact. Ah, yeah. Oh, fucking yes, 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 yes. Because you want to use groups to run the two matrices in parallel, but we like as if they were actually two. I don't know if you guys are familiar with groups in convolution in PyTorch. So basically, by default, groups is one. So basically, it basically means, you know, I just gonna run all of them on the input like a normal convolution. I think with convolution 2D, it's easier to understand. So let's go back on. Yeah. So can you see my paint, right? Okay. So if I have something like this, I mean, I am familiar with them in 2D. And let's assume that I have two features, two channels, and whatever. If I have a group of ones, then my convolution will be basically, you know, run on all the features in one go, right? If I have a group of twos, I will run, you know, one here on this one and one individually on the other one, but in parallel. And in the depth-wise conv, you want to basically have groups equal to a number of features and one kernel, basically, if I remember correctly. But that makes sense. It's yeah, it's highly efficient because I guess use some CUDA stuff under the hood, right, to do that actually in parallel. Yeah, so basically you will use two actually different sets of weights in that case. So basically your weights will be basically separated in two, and the first one we run here and the second one we run on the other one. I'm not sure. I cannot draw that from con 1D because so for con 1D you have something like that, right? And so let's see, we have like sequence length of 3, right? And we have two features. So sorry, fuck. How can I go back? Okay, and correct me if my drawing it's crap, because I'm not really familiar to think in this kind of stuff. And we have like two features. So if now if I have groups equal 1, right, it means that I'm gonna and sorry, and kernel equal 1, okay, it means that I'm gonna do first this guy, then this guy, and then so on, right? I'm looking for some validation, guys. Okay. If I have group equal choose, it means that I'm gonna do this with one set of weights, you know, and with one half of the weights, and this with another half, and then I'm gonna do this with another half, blah blah. So it basically it will be the same thing of running, you know, two convolution in parallel, you know, on the first row and the second row, you know, and then the output that we get, I mean, the first part will be basically, you know, all the things here, and the second part will be all the things down here, like, but they have never seen each other. So yeah, so that kind of makes sense, because so basically here we have like the queries, you know, this guy here, and here we have like the keys, and we want to have like one LoRA for the keys and one LoRA for the queries. But, you know, we are using this, I don't want to call it a trick, but, you know, with this convolution, basically we are able to get our LoRA metrics for both keys and queries at the same time on the input, but in parallel. So they're kind of independent by each other. So like they don't mix weights. I mean, they don't leak information to one on another, right? Because if I have the same weight looking at this thing at the same time, I'm leaking information to one part to the other, right? And we don't want to do that, because we just want to do them individually. I guess that we could do the same thing in a for loop, right? So let's assume, I have my merge layer and I have keys and values. I can just create, one BA for the queries, one BA for the keys, and then I do a for loop, right? So I mean, I just compute this and then I just compute that, but it's slower. And this will be done at the same time, basically. If that makes sense to you. Okay, cool. I'm a terrible paint user, but okay, so yeah, I think that now I have a way better understanding of LoRa, to be honest, compared to before, because like before I knew it more or less, like I knew it, the advantages, because I was using them in Stable Diffusion and automatic 11 level, but I didn't really know under the hood too much. I knew it that you have this layer in the middle, blah blah, and then I think a new thing actually is out, something called LoRA, which I don't think if you are I'm not familiar with it. I don't know if any of you is. Yeah, because I think it's late for you, right? Yeah, because I think that the Q in LoRa stands for quantized, right? So I guess like my gut feeling will be that they have the model quantized, and they do LoRa in the quantized model, which is faster by default, because we have less. Ooh. And do you know that in theory, so let me check who LoRa. Oh, here we go. So let me check it, because in theory, yeah, I met this guy because it was at my university, and I, if you want, guys, I have a very fun story about him, like that really proves that I am stupid. So we were working together and with another classmates on real-time sentiment analysis of tweets. It was 5 years ago, I just implemented a model with a convolution. It was working, yeah, more or less fine, and I needed to test it, right? So what I started to do, I basically created some strings, and in one string I say Luigi is a nice guy, and Luigi was a classmate, a team member, and in another one I say Tim is a piece of shit, and just because I want to test the sentiment, right? Then I commit this test, and Tim, he read the test on GitHub, and went to the professor, say, like Francesco is saying some bad things about about me, you know. So I was called to the professor, and the professor said like, why did you say that team is, I don't remember if it was like team is a piece of shit, okay. You know, and of course, like I didn't have anything against him. It's a super smart guy, a very 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 smart guy. And it was just like, you know, I just, you know, I was just kind of testing with, you know, with random emotions, and I was just thinking about my teammates, you know, and then everything was okay. But after that, I think that team believes that, you know, I had something against him. So that's is a fun story. I don't know. I don't know. I can try. I can try. But yeah, but you know, I was follow his work a little bit. So he work a lot on these advanced ways, you know, to reduce the number of bits that you need to run model, like 8 bit or 4 bit. And he has this library here. It's called bits and bytes, which is basically, yeah, so basically it's a binding for the 8-bit CUDA stuff in PyTorch. And yeah, so because by default, I guess on some GPUs have support for 8-bit stuff, so like unsigned int 8, but they're not really supported in PyTorch. I mean, at least that's my understanding. And with this library here, you can basically, you know, you can do the 8-bit things on GPU. So he has some binding to Hugging Face, and yeah, you can also, you know, just create stuff. It also has another implement. He also has some implementation of the optimizers in 8-bit, and there is a video on YouTube about him talking about the paper behind the project. Yeah, I think it's this video here. Yeah, and yeah, this is also a nice video to see, because it goes into, you know, into the understanding, you know, how you need to do it, how you need to quantize, how you need to rescale, and what do you need to do to actually train. So I'm just gonna post that on Discord. It's just like 12 minutes long. Oh, and they also have a 1 hour with Cohere. I don't know how to pronounce that. I'm just gonna post this here as well for you if you want to take a look when you are, I don't know, eating or on the toilet. And yeah. So yeah, so I guess for LoRA that we can close it here. Thanks a lot for your wisdom and insight, and the willingness, you know, to stay happy night and have a chat with all the Jedi's here. And yeah, and I don't know if the others, they want to stay here and read something else. For us, it's still kind of not late. Okay. Yeah. Yeah, have a nice one, man, and thank you so much. Thank you so much. Bye. Have a good night. Bye. Bye. Yeah, sure. Thank you so much. Bye. So looks like Mr. Robot has died. So it's not here anymore. I can't see him. Yeah, I'm gonna go 1 second to the bathroom. Gonna be, yeah, just 1 sec. Okay, so let me close the recording.